Welcome to Ask and Learn.
Okay, first I need a picture of this thing, and if it didn't have this 4 in front of the y squared, it would be a circle whose radius is 2 and center is 0, 0. But with the 4 there, I know it's an ellipse instead. So it's x squared over 4 plus y squared over 1 equals 1. So when I draw it, it's 2 on the x-axis, 1 on the y-axis, and then it's that ellipse. Okay, so first we're going to send it around the line y equals 2, which doesn't touch it. So it's going to go around and it'll make a kind of a ring-looking thing, like a baby floaty, maybe like the kind they wear on their arm. Looks kind of like that. Okay, so how should we cut it? Well, if we want shells, we're going to cut it horizontally. If we want discs, we're going to cut it vertically. I'm just going to do discs. Okay, so I'm going to cut it like this. So I send this piece around and it makes a flat washer, and it's real big because of the distance here. Okay, like this. And because this right here isn't touching this dotted line, you can see that's going to make a hole in it right there. Oops. Okay. Okay, let me give that hole another try there. Okay, that's a little bit better. Okay, the volume of that thing washer is pi, big R squared minus little r squared h. And h is the thickness of this piece right here, which is the thickness right here, which you can see is dx. Okay, and then r is the distance from the center to the outside of the washer. All right, so it's the distance from here to here. All right, so we know that from here to here is 2, and then from the x-axis to the outside here is some y value. So big R is 2 plus y. And then little r is the distance from the center to that edge of the hole, which is right here. So we know that that one is also 2, but this time it's minus that y value. Okay, because it's the difference between those two. Or this green arrow plus this blue squiggly add up to this blue squiggly. So little r is 2 minus y. Okay, so we can't put that in because we're going to integrate with respect to x. So we have to get the y out of here. So I'm going to solve the equation for y. So I get y squared equals 1 minus x squared over 4. And so y is plus or minus the square root of 1 minus x squared over 4. But the way I have it written here, I'm going to use the plus both times. I'm going to do 2 plus y and then 2 minus y. So big R is 2 plus that square root, and little r is 2 minus that square root. All right, so then it's magically gone. Okay, there it is. Okay, so then the volume is going to be the integral pi times big R squared, 2 plus 1 minus x squared over 4, quantity squared, minus little r squared, which is 2 plus the, 2 minus the square root of 1 minus x squared over 4 squared dx. And then we're stacking these little disc washer things up from x equals -2 to x equals 2. So we could do -2 to 2, or we could do twice 0 to 2. So let's just do that, make it easier. So it's 2 pi 0 to 2. Let's go ahead and simplify a little bit, and then it won't be so hard to type in the calculator. This will be 4 plus 4 times that square root plus that square root squared minus, oh, I gotta be careful here, 4 minus 4, that square root, 1 minus x squared over 4, plus 1 minus x squared over 4. And then dx at the end. Oh, 2 pi, 0 to 2. Okay, this 4 and this 4 cancel because it's 4 minus 4. This 1 minus x squared over 4, that cancels with that. So we have 4 minus 4. So we have 8 square root of 1 minus x squared over 4 dx, or 16 pi, 0 to 2, 1 minus x squared over 4 dx. All right, I don't have the kind of calculator where you integrate. Oh, I guess I could have found an integral calculator on the computer, but find something that will integrate that, and then out will come the answer. Okay, now let's send it around the line x equals 2. Okay, so remember it looked like this. So now we're going to send it around this line. Shells or discs? Let's just do disc again, since we know how to do that. No, let's do shells. That'll be more fun anyway. Oops. All right. So to make shells, I'm gonna cut it this way. Okay, and then I'm gonna send it around. Okay, so here's one of the shells. And then there's a little tiny one here, and then, okay, this looks sort of like a big fat donut that is so puffy, the hole got completely filled up right here. Okay. Okay, volume of shell, 2 pi RHT. Okay, so here's the shell. T is the thickness, and you can see the thickness here is dx. H is the height from the bottom to the top. So you can see if I draw one of these, the height is y plus y, so 2y. And then r is the radius of the shell. So r is from the axis of rotation out to here. So the axis of rotation, remember, is 2. And then this is some x value. So that radius is 2 minus x. All right, and then remember we solved for y and we got plus or minus the square root of 1 minus x squared over 4. So that's what's going to go here. All right, so the volume is 2 pi integral r h t, and we're stacking the shells up from here all the way to here. So -2 to 2 again. Okay, so we can do 0. This time we can't. Okay, we can't do 0 to 2 and then do it twice, because this little shell is way different than its partner out here. It would be really big like that. So you're going to have to do -2 to 2 on this one. Simplification you could do. Oh, I made a mistake right there. Oops. Okay, remember that only the x squared is under the 4, not the 1. But you could do that. 2 pi minus 2 to 2, 2 minus x. You could write that as 4 minus x squared over the square root of 4. So this 2 and that would cancel. All right, so now that's ready to go. So put that in your calculator and see what you get there. Okay, I hope that helped and didn't confuse you with this way that I did the volume. But it's really easy to think about this way if you just always remember one's 2 pi r h t and the other one's pi r squared h.